Today we are going to discuss something about Coulomb's law. Something means Coulomb's law. We are discussing Coulomb's law. What is Coulomb's law? And basically there are two types of charges, negative charge and positive charge. Each and every material is made up of ultimately atoms, and atoms consist of electrons, protons and neutrons. These three particles are also known as fundamental particles or subatomic particles. In electron there is a negative charge, in proton there is a positive charge, and neutron is neutral. So basically any object, if it is charged because of one of the two particles, whether it be electrons or protons. If an object is positively charged, then we say that it has lost its some electrons, therefore it is positively charged. And if an object is negatively charged, then we say that it has gained some electrons, therefore it has become negatively charged. But why we are not talking about the movement of protons? Because protons are tightly held or strongly held inside the nucleus. They cannot move outside of the nucleus. Therefore whenever there is a transfer of charge in or from atoms, that must be due to electrons and not because of protons. Now in nature there are two types of charges, as we have already discussed, positive charge and negative charge. And we know that if there are two positive charges or two negative charges, then these charges, that is like charges, repel each other. And similarly these two negative charges are together, therefore they will also repel each other. But somehow if we have a positive charge and a negative charge, then this pair of charges will attract each other, and we say that unlike charges attract each other. Whether it be repulsion or attraction, it is a force, and this force is given by Coulomb's law. And Coulomb's law states that if there are two charges, and we can name the charges, suppose, let me erase it. Suppose there are two charges, charge q1 and charge q2, separated by a distance r. Then there exists a force of attraction if the charges are unlike, and a force of repulsion if the charges are like. So this force F is directly proportional to the product of charges q1 into q2, as states Coulomb's law. And similarly this force depends on the distance between the charges, and it is 1 by r square, that is F is inversely proportional to the square of the distance between the two charges. And one thing to remember, that this distance is the distance between the centers of the charges. Now if we combine these two equations or proportionalities, we get F proportional q1 q2 upon r square. And whenever we remove the sign of proportionality, we have a constant, say k, q1 q2 upon r square. This is Coulomb's law in mathematical form, and this force is known as Coulomb's force. Further, this k can be factored as a constant 1 upon 4 pi epsilon naught. This 4 pi we know, 4 and pi, and epsilon naught is known as permittivity of the free space, and it has a value 8.85. Let me write it. Epsilon naught has a value of 8.85 into 10 raised to the power minus 12, and let us write its unit, and this will be